All right, guys. So today during class, you were supposed to work on your practice book, which is page 163 in your Math Nation practice book. All right. So this is section 10, topic 4. And if you did your homework last night and you took the notes from yesterday's class, this should be relatively easy, but it's just some extra practice for you either way. So let's go ahead and look at what they've provided for us in question 1. It says below is a table of values for the number of pictures added each year to the Tampa Tribune's database since 2000. Okay, so these are years since 2000. So we have 2000 all the way through 2014. So they surveyed 14 years total. Okay, they provided the scatter plot. They completed the scatter plot for you below. That's what this is. They took this data from the table and they input it into the scatter plot, and then they asked you questions part A through H. All right, so let's look at these questions because these are the same questions that I asked you in the forms assignment for your classwork on January 12th. So what do the values of the x-axis represent? Okay, again, our x-axis is this down here, and that represents the years after 2000. Okay, so that's the number of years after 2000. Part B, what do the values on the x-axis, on the y-axis represent? So this here is my y-axis, and that is the number of pictures added each year. So number of pictures added each year. Part C, what does the value 6, 410? And I want you to remember, when we are given an ordered pair, we are given an x and a y value. So that x and y value coordinates to this point right here on the scatter plot, or this value here in the table. So what does it represent? Well, that represents that in 2006, 410 pictures were added. Okay, it is not saying that in 6 years 410 pictures were added. It means that 6 years since 2000, therefore 2006, in 2006, 410 pictures were added to the database. Part D, what type of correlation is there in the scatter plot? So when we're talking about correlation, we're talking about what we did yesterday, and that's that line of fit, okay? So if I drew my line to be in the middle of my data points, my scatters, right, what does that look like? Does that shape look like a linear function or a quadratic function or an exponential function? Well, that is a linear function, right? Because it's just a straight line. There's a slight incline going up. So that's why it's asking, is it a positive, negative, 0, or undetermined? Okay, well, the answer here is positive. Okay, there is a positive correlation. It does look pretty flat, but there is a slight increase. So we're going to identify that as a positive correlation. Part F. Which of the following is closest to the regression line equation? Okay, so we've already identified that we have a linear correlation and that it's a positive correlation. So looking at my answer choices, I've got A, B, C, and D. Let's see. A says 366x plus 8. Well, this 8 here would have to tell me the y-intercept, and that 8 does not make sense for my y-intercept. Okay, so I'm going to go ahead and cross that off. Also, A is showing me, oh, that slope of 366, and that is way too high. That is way too steep, okay? Part B, option B, is showing me an exponential function. So I'm going to cross that one out. And then we have part C, which is 8x plus 366. And this 366 makes a lot of sense based on my y-intercept over here on the y-axis is 366. So C is the best answer, okay? That is the equation that matches that function. Part G. In approximately what year is the Tampa Tribune expecting to add 700 new pictures per year to their database? Well, in order to figure that out, what we need to do is we have to take this 700 and plug it into the equation that they just gave us. But this 700 is the output, not the input. So my equation is going to look like this. 700 is equal to 8x plus 366. Because again, that 700 stands for my y value, not my x value. So I'm going to plug it in on where my y or f of x would normally be. Now that I have my equation, I can solve that equation. So what I'm going to do is I'm going to subtract 366 from both sides. And I get 334 is equal to 8x. Then I divide by 8 and divide by 8. And I find that x is equal to 41.75. Okay? So, and that will be in the year 2041. So x is equal to 41.75 in 2041. That is the answer to part G of this question. Part H, James says that at some point the number of new pictures being added will begin to decrease. Does the data for the past 15 years support his hypothesis? Well, based on the data that they've taken for the past 14 years, the number of pictures added to the database has increased. So James is incorrect. So no. And why is that? That's because the number of pictures added has increased. So the pictures increased each year. So as the years increased. So the pictures increased as years increased. Okay. So that is question 1. Let's move on to question 2. Okay, question 2 has our multiple parts. It says match the following words to the scatter plots below. Each word may be used more than once. Now I went a little bit further and I wanted you to identify if it was positive or negative, not just exponential, quadratic, or linear. So looking at this data for this first graph, that is definitely a positive linear function would be the best fit. That's the correlation, okay? I look at this next one. Well, that is definitely a quadratic. And remember from our notes yesterday, if it's opening down, it is a negative quadratic function. So negative. Looking at this function, what does that look like? Well, that looks like an exponential. And what we called yesterday positive, but I want you to be in the habit of calling that growth. That's exponential growth or positive, okay? Next, we have this data. Well, that looks like a quadratic to me. and it's opening upwards, so it's positive. Okay, this next graph, that is a linear function for sure. And it doesn't really even look positive or negative. It looks like a 0, meaning it's a horizontal line, so that would be 0. But you just need to know that it's a linear correlation. Then we have this data here, and that is exponential. Well, if the one before was exponential growth and it was going up to the right, and this one is showing me is going up to the left, or if I drew a line like that, that looks like it's going down. So that's showing me exponential decay or negative, okay? That is a negative exponential function, but we should be in the habit moving forward of calling that an exponential decay because it's getting smaller. Then we have this next one, which is linear, and this is a negative linear. Looks like it's going down. And then finally, we have one more exponential, and this looks like growth. So it's exponential growth. It is as my x is increasing, my y is increasing. All right, so those 8 questions are finished. Okay, those are 8 separate questions in the forms assignment. So let's get to question 3. It says, when a movie released to theaters, production companies monitor revenues from individual cities for that movie on its release date. Below is a table that shows 10 different movie revenues from the opening night in both Tallahassee and Gainesville. Revenue is reported in millions of dollars. So we have Tallahassee and we have Gainesville. Well, I'm going to put Tallahassee here on my x-axis, and I'm going to do Gainesville on my y-axis. Okay, and I'm going to label it as such. So I'm going to put Gainesville here. There's 2 L's in Gainesville. And Tallahassee here. All right. Now I need to identify the coordinates in my graph, and so I'm going to go by 5s. And I'm going to zoom in a little bit so you can see this better. Oops. Okay, so we're going to do 5. Oops. Why is it not letting me draw? 5, 10, 15, 20, 25, you get the idea. 5, 10, 15, 20, 25, 30, you get the idea. So, I need to go all the way up to 35. Okay. And we're going to go 5, 30, 35, 40. Okay. So represent the data on the scatter plot. So when Tallahassee was at 1.6, right? I had a point, my Gainesville revenue was 35.7. So 35.7, I'm going to be about right there. At 5.2 for my Tallahassee, I was at 34 for Gainesville. 34, right here. Okay, 10.1, go down to 32.6. Right here. 15.9, I'm at 29.2. Right there. 18.4, and I went up a little bit, so I'm at 34. 21.3, I'm at 21.7 right here. 25.1, and I'm at 18.3. You kind of get the idea of what's happening here, okay? So we have our scatter plots, and it looks like we have a negative linear function. So which is the more appropriate function to model the data? So again, we have a negative linear. So which ones can we remove? Well, B is positive, and we clearly have a negative linear function here. D is exponential, right? C is quadratic, and I knew that because of the exponent right there, and my exponential I knew because of my variable is in the exponent, okay? B was a positive linear because that first term was positive, so that means my only answer choice here is A, okay? So A would be the best fit for this data. So according to the model, if a movie brought in 32.2 million in total sales in Tallahassee, what would be the expected sales for Gainesville? So according to what we have here for our equation, our f of x, that's our y, so that is equal to Gainesville. And our x value, that is equal to Tallahassee. Okay, so if a movie brought in 32.2 million for total sales in Tallahassee, that's my x value. I have to plug in that x value and find f of 32.2, and that's going to equal negative 0.805 multiplied by 32.2. Okay, this is what I'm plugging in here for my x value, plus 38.967. So if I do 0.805 times 32.2 and then add 38.967, I'm going to get 13.046. But we are dealing with millions, okay? So don't forget that we are talking about millions. So it's 13.046 million dollars, right? Or if I wrote that out in standard form, then it would be 13,046,000, just like that, okay? So this is your correct answer. It's not $13.05. It's not $13.05, okay? The answer to this question is 13,046,000. Okay, you do not have to worry about part D. Okay, that was not a question on the forms. So those are the answers to your practice book questions. Please make sure you use this resource and correct your answers if you got it wrong.